Okay, we are in code blocks. Not that that's relevant to the actual project, but yes, code blocks, and this is a prelude to a project where we use a stack. So step 1, not step 12, is create stack. Our second step is use stack. And finally, we get to step 3, which is pure profit. If I could spell profit. Now, when I say create stack, we obviously could just be very straightforward and do an include stack call up here. But that's not what we are going to do. We are actually going to build a stack from scratch. And actually leave that up there. And if you aren't familiar with a stack, let's just go over it. I don't even know what I was doing here. So yep, anyway, we are familiar, or at least you should intuitively know, that when I say data structure, I mean some way of storing data in a program. So you obviously are most familiar with a list, maybe a vector, maybe if you come from Python, you are familiar with a tuple or a dictionary. But what is a stack? So initially I have nothing, as you can see here. What a stack does is, you create an object, such as here, let's just call it object 1, and then we can create another object, let's call it object 2, and let me make things clear and say that this is our stack, all right? This is the stack. Anything that falls in this region is the stack. Right now, our stack has one object called 1. If I take object 2 and I push it to the stack, it will sit atop object 1. Let's make it closer. There we go. So now the top of the stack is object 2. And say I create another object, and let's call that object 3. And if I push that to the top of the stack, it will now be here. I have object 1, I have object 2, and I have object 3. But what a stack says is, we can only add objects to the top, and we can only remove objects from the top. In this way, it follows a last in, first out structure. The last added data will be the first removed data. So if we were to call stack.pop, what will only be removed is the top of the stack, in that case 3. If we call stack.pop again, what will be removed is the top of the stack, that being 2. And if we call stack.pop the last time, what will be removed is 1. And now again, there are a few more restrictions, such as when we push an object to a stack, it adds a new element to the stack. And if we do it again, before we do that, this 3 will be the top of the stack. We push it again, we now get the top of the stack being 2. We push it again, now the top of the stack is 1. Essentially, it mimics a structure of cards, so playing cards, but you can only remove items from the top of the stack. So yeah, very simple, very straightforward. I'll actually remove this, and I will do creating and using a stack. I will come here and I will go, let's do file, new class, and I will call it stack abstract data type. Do I want it to edit current project? Yes, I do. Do I want it in a separate folder? Okay, you know what, let's remove that. Remove, and I'll also remove that. And I'll add it again. And stack abstract data type. I won't need a destructor. because this will be a parent class, and I won't be using virtual memory. Okay, and where do I want it? My header file, and I don't want an implementation file. I have them all in one file. And create. There we go. All right. And we will have 6 operations in our stack. These operations being, we will initialize the stack, we will check if the stack is full, we will check if it is empty, we will push obviously because we have to add objects, we will check the top of the stack, and we will pop the stack. So initialize essentially creates the stack, or should I say sets it to an empty state. Is full, checks if the stack is full. Is empty, checks if the stack is empty. Push adds an object to the stack, always adds to the top. Top returns the topmost, or should I say top element of the stack. And pop removes the top element of the stack. Obviously there are other conditions that must be met, such as if the stack is full, obviously we can't push. If the stack is empty, we obviously cannot pop. I will make this class an abstract class, and the reason I am doing this is just that I'm not restricted to one data type. I do not need a constructor, so I will get rid of that. And the first thing I will do is I will create a virtual function which returns nothing, called init stack. Again, this will serve to be a parent class, therefore there is no need for me to have it to not be virtual. So all this does is a member function, so method to initialize stack to an empty state. I then will have my virtual Boolean function, which checks if my stack is full. This one simply returns stack is full. So either true or false depending on the condition of whether the stack is full or not. I'll then create another virtual function is empty. And this one returns stack is empty. We will then have another virtual function, and this one is a void function because all we are doing is pushing an object to the top of our stack. And it will take as parameter some constant type, and let's just call it item. Set that to 0. Add item to top of stack. Then we'll do a virtual function which will return type called top. All this does is return the topmost element of the stack. And our final virtual function and final function in general is the pop function, which is very simple. We can have this returning a type, so when you pop from the stack, you also return the value. Can be useful, but for this case, we're not doing it. Remove topmost element from stack. And we don't have a private or protected scope, so there's no need for us to do any of that. Now, these are all pure virtual functions, so we only need the definition. Nope, we only need to declare them without having to define them. Now, how do we actually implement our stack? We can implement using a linked list, but I think an easier way for us to do it is to implement using an array. So the first element of the stack will be put in the first array slot, the second element in the second array slot, the third element in the third array slot, and so on. We can keep a reference to the top of the stack as the index of the last element added to the stack. So let's go back to our sources and we will add a new file. Or should I say new class? There we go. It will be called stack type because we are using templates and we call our class type. Any arguments? Nope. Has destructor, has virtual destructor. A virtual destructor, no, but a destructor, yes. Has copy constructor, nope. Has assignment. Should we be able to copy our stack? We can do that. I will have the assignment operator. Inherits another class, yes. And actually I will do this myself. I'll get rid of that. Add part to projects. And I will have my header file and my implementation file in one. Stack type, okay. Alrighty. Stack type. Why am I including the same file? Stack abstract data type. There we go. Right. And this too will be a template class, not class, template class of type. This I don't think I'll be needing, and this should come at the end. So I'll leave that there. Const stack type, which will take type. I will define this later on. Const stack type and type other. And this is overloading the assignment operator. That will be our first function. We now will have a init stack. Did I call it a init or did I call it init stack? I called it a init stack, okay. Init stack. Declared in parent must be defined in child. So we have to define it here. Then we will just copy and paste all our functions. So is full, who is empty. I am probably going to get the spelling of these wrong, but it is what it is. I then have my void push. What did I call the parameter? This. Okay. And I think I actually should have consistent const, okay. A void push. I return a type called top, and all that does is return the top element of my stack. And finally, void pop. And let's add the constructors up here. And we can pass in some initial size, so in this case we'll just pass in 100. Let us create the copy constructor as well. Which has to take as parameter another stack. This should appear after my assignment operator, just so that I know that I'm using the assignment operator to implement the copy constructor. And do I have, yeah, I have my destructor, okay. Anything in protected? Nope. Anything in private? Yes. I have an integer called max stack size, and an integer called stack top. This is not the value of the top of the stack, but rather a variable to point to the top of the stack. Type called list, just then pointer to the array that holds the stack elements. And finally, a function. Actually, okay, I'm just implement it. And other stack, okay. So let us start implementing our functions. Now let's do type, and I want my init. Stack type. Oh, okay, init stack. I have the wrong name. And as I said, all this does is initialize the stack to an empty state, or should I say fresh state. All we have to do is hit stack top and assign that value 0. Now, let us do our simple Boolean function. So bool stack type, pass in type, which means I need to have my template up here, and is full. You're not appearing in my scope. Is bool, right, stack type. Do I have an error somewhere? Template class type, stack type is full. I have a feeling something's wrong. And all this does is return stack top equal to max stack size. I have template class type, a Boolean function stack type, and because it is a parameter class, I need to pass in type, and is empty, empty, and const again. This one is very simple. I return the stack top is equal to 0. Now, when we push an element, we do two things. We add the element to the top of the stack and we increment stack top. So template class type void stack type. Why do I keep on spelling that wrong? And this one is just push, not pushback, just push. What parameter? Const type and item. But we have to ensure that our stack is not full. So if is full, because you're passing in a not. Once this checks out to false, we invert it to true, and then we run our actual logic. List stack top is equal to new item. Or should I just say my item? And stack top plus plus to indicate a movement of the top of the stack. Else stack is full, cannot add more elements. I should also do using namespace standard. And I think I won't have to. I don't think I'll get away without adding the IO stream. Okay. Template. And we obviously have to return the top of our stack. This one is quite simple. We return list at stack top minus 1. But before doing that, let us assert that stack top is not equal to 0. This will terminate the program if the stack is empty. We could also just do if stack empty, do this, else do something else. That's also possible. We now do our pop template class type void stack type pop. Or should I say pop? If not is empty, we'll go on itch. Is it empty? Yeah, is empty. Because obviously we cannot pop an element if that element does not exist. Stack top minus minus. Else okay. We now do our copy function. And void stack type And copy stack. Let me go ahead and copy the parameters. Okay, that should be it. Let's see. So firstly, I want to clear out my first list, and then max stack size is equal to other stack dot max stack size. Then stack top is equal to other dot stack top. List will create using dynamic memory allocation, so new type of max stack size. And now all we do is a for loop. So int, let's do I is equal to 0, I is less than stack top, I plus plus. All we're going to do is say list at position I is equal to other stack dot list at position I. And this way we populate our list. And now we have a copy of the stack. Let us create, actually let's let me go to the top and create my constructor. Okay. Template class type and do a stack type. And int stack size. Now you can pass and initialize a list, but because I have some logic here and I also want to present the user with some helpful information, I will not be doing that. If stack size is less than or equal to 0, then size of array is invalid. Do an end line, and we'll do another one, just so then we make the user aware of what is being done. Setting stack size to 100. So let's say the user just mistakenly adds 0 or say -5 as stack size. We will not allow that. Max stack size, and we shall initialize it to 100 objects max. Else max stack size is equal to stack size. If they want to go overboard, that is fine. Stack top is equal to 0 to represent the location, or the location. List is equal to a new list by using dynamic memory allocation, max stack size. And that is the end of our constructor. And let's go down to the bottom and do our destructor. Let me check something. Okay. Down here, and it should be stack type, and then stack type. I should not forget to do this. I usually do forget to add my template specifier on top. And all I do is delete the list to free up the memory. Let's put my copy constructor right here. So template class again. stack type. I feel as though my earlier explanation of a stack was not good enough, so as soon as I am done coding, I will go back and explain something using a more realistic example. Other stack. This one is very simple. We initialize the list of our current stack to null pointer, and then all we do is call the copy stack function that we created earlier, and we pass in other stack. We must now overload the header, overload the assignment operator. So template class. Ooh, that's wrong. Template class. That's also wrong. Type and const stack type, and we shall no. Oh, am I getting my specifiers wrong? I think I am. It should be. I always get this one wrong. So it's okay. So it should be and stack type operator equals to, because you overload the equals to operator, or should I say the assignment operator to be more transparent. That is so loud, my bad. Cons stack type. We have to pass in type because we created it to be a template class. And other stack. And we don't just copy if this is not equal to and but this refers to the current calling object. Other stack. We will then do a copy stack, passing in other stack, and we will return this as a pointer. Okay, everything should be good. Let's just bold and see if we get any errors. Okay, we have no errors, but that doesn't mean we actually have no errors. We also have to check our file here. So let's just include stack type, and now stack type, no such file directory, stack type .h. No such file stack type.h. Interesting. So if I do hashtag include yeah, why is there space there? It should be .h. There should be no space. .h. Why is it coming up as that? No such file or directory. So right here, mate. So I'm including my stack abstract data type, my stack type.h. What if I were to do strap? So that's fine. But for some reason, did I forget to add it to my project? Nope, it's right here. Stack type .h, stacktype.h. But there should be one space there, because it seems like I spelled something wrong. Yeah, I did. A few errors here and there. And let's do it again. Okay, so here I missed out to add in type. Stack top was not declared. I think it was declared, mate. Stack top, there we go. Stack top was declared. There are no arguments to assert that depend on a template parameter, so a declaration of assert. Is it in C assert? I do not remember. Are you in C assert or are you in assert? I think it's C assert. C assert, that should fix that. Expected before if. That's here, okay. Which means the error is before this primary expression. If not is empty. Variable or field pop declared void. Variable or field pop declared void. Pop is a void function. Void pop, right? And void is pop. Come here and is it a const? Nope, it's not. Is full is empty top, so that's fine. That's fine. 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 This is also fine. Top is fine. That's so loud. My apologies. Void stack type pop, and it's because I missed my function initialization. And then other was not declared in the scope. Yes, because it should be other stack. But my pbrain rushed. And that should be it. Extra tokens at end off. Yes, I know, I have more here than expected. Big deal. Go back into our main. Okay, so we have created the stack. Everything should be working, but it is not enough just to say that. Let us test out some of the operations of the stack. So this, we have our stack, and because of bad naming on my part, I unfortunately created it as not stack type, but rather stack type space. Unfortunately, but not a big deal. Let's just create the stack and see at minimum if the stack exists. I will create a stack of, let's just say, integers, and I will call it stack. And first let me create -1. Creating and using a stack, size of array is invalid, set in stack size to 100. Great. So I know that my constructor is working. Let's do 100. Creating and using a stack, okay, that's great. Let me, if there's no error, do I want to add a success message? Nah, it's fine. Stack type, create an integer. Let's set this to a more reasonable value, such as 10. Now create a copy stack. And it will also be 10. And I'll create one last stack of integers, and you will call it dummy stack. And let's do you 20. Stack.initialize stack. Let's push the value 1. And let's repeat this a few times. Let's do stack.push 2. Stack.push 3. And I will also do copy stack is equal to stack. So now they both should have, going from the bottom, 1, 2, 3. And let's do cout the elements of stack and copy stack are as follows. While not dot is empty. So as long as we have elements in our stack, we will do a cout copy stack dot top, and we'll do a space, and why do I have let's do and let us no let's just do copy stack for now. The elements of copy stack are as follows. We'll give space, we'll complete that line, and we have to pop out the element from copy stack just to ensure that we do not get stuck in an infinite loop dot pop. We get 3, 2, 1, but let's actually make it look like a stack and do an end L. And there we go, 3, 2, 1. So far, so good. Let us come up here and create a function. Let's call you void test copy constructor. And you will take as parameter some stack type, an integer, and we shall pass it the parameter name of other stack. Declared up here, and we shall define it down here. And we shall say void test copy constructor, stack type integer, other stack. If not other stack dot is empty, and let us also do top element is dot top. That should be enough. And let's say copy stack is equal to stack again. So now we repopulate the copy stack. And let's do test copy constructor, and let's pass in copy stack. Or should I say stack? Cannot convert. Okay, yeah, makes sense. And there we go, the top element is 3, other stack is not empty. Okay, so everything is working so far. And step 1 is done. Step 2, we have used the stack, but we will use it in a more practical sense in the next video. And that is it for this one.